All right, in this lesson, we're going to be looking at double displacement reactions. The bell ringer for this lesson is to complete a single replacement reaction, and you should be able to do this using what was taught in the previous lesson on single replacement. So for double displacement reactions, I'm going to use the analogy wife swap. It was a TV show that was on in the last couple of years, and it perfectly models what we're going to be doing with double displacement. So on the show wife swap, we have two couples. We have couple one, husband and wife, and we have couple two, husband and wife. And the husband from one couple, or couple one, would match up with the wife from couple two, and then the wife from couple one would match up with the husband from couple two. And when we do this in chemistry, we are going to be matching up the cations, cation, with the anion. So think of the husbands as the cations and the wives as the anions. So cation from couple one matches up with anion from couple two. Anion from couple one matches up with cation from couple two. So the steps for this double replacement reaction are similar to what we were doing with single replacement. So cations match up with anions, but this is going to happen twice, not just once. Okay, so the anion is going to match up with the cation, and the cation is going to match up with the anion. So when we do this, we want to be careful, though, to make sure that we're still writing the cation first, and then, of course, when we're all done, we balance the reaction. So let's look at a couple of examples. All right, in our first example, we have a polyatomic. We have carbonate, CO3. So our first step is going to be to write out all of the charges, and I'm going to try to do this in different colors. So our cations, I'm going to write in red. So we've got potassium. Potassium has a charge of +1. And barium, from our second compound, has a charge of +2. I'm going to write our anions in blue. So carbonate, if we look it up on our table, has a charge of -2. And chlorine has a charge of -1. Okay, so our first step is always to write out the charges. Step 2 is going to be to do our quote-unquote wife swap. So cation matches up with anion. Let's see if my pen will cooperate. Cation matches up with anion. Anion matches up with cation. Okay, so when I write this out, I'm still going to be watching for charges. So I still want to make sure that our charges equal out to 0. So for my first compound, potassium and chlorine, both have a charge of 1. They're opposite. One is positive, one's negative, but they both have a charge of 1. So I can go ahead and write this out as potassium chloride. Okay, and then for number 2, let me do this in a different color. I've got my two charges here. Both are a magnitude of 2. But opposite, so one's positive, one's negative. So I'm going to write this out as barium carbonate, CO3. All right. So at this point, it's just like what we were doing before. We're going to balance our reactions. So the only difference between single replacement and double replacement is that we have cation matching up with anion twice. There's nothing left over like before. We don't have to worry about diatomics. So in a sense, this is actually a little easier than single replacement. So when we go to balance, let's go ahead and write out our table. All right, so I'm going to take an inventory of what we have. So remember, these numbers, the subscripts tell us that the subscripts tell us how many of each we have. So we have 2 potassiums, we have 3 carbonates. If it doesn't tell you, like in the case of barium, we assume it's a 1 and 2 chlorines. So I'm going to do the same thing on the other side, just fill in what we have. Oh, I made a mistake. My carbonate, that 3 is part of the carbonate, so we actually only have 1. Okay. So to balance this reaction, all I need to do is put a 2 in front here. That's going to give me 2 potassiums and 2 chlorines. And that's all we need to do to balance the first one. Give us an easy one to start off. All right, let's look at example number 2. So same thing. We're always going to start by listing out our charges. However, for this example, if you notice, we have iron here. Iron is one of those transition metals where we don't know the charge. We have to look at what it's attached to. So let's go ahead and do that. So I'm going to write this off to the side. So we have iron and we have bromine. Okay, bromine has a charge of -1. All of our compounds are going to be neutral. They're going to have no charge, or they're going to have a net charge of 0. So bromine has a charge of 1, but there are 3 of them. So -1 times, oops, that was not -1, that was -3. -1 times 3 gives us a charge of -3. So I want iron to balance out with that. So iron's charge has to be +3. And the reason being, iron has a charge of +3, bromine has a charge of -3. So I'm going to end up with a net charge of 0, which is what we want. So let's write out our charges now. So I've got iron, which has a charge of +3. We just figured that out. And potassium on compound 2 has a charge of +1. All right, so we have, let's see, bromine is our anion in this case, and SO4 sulfate, SO4 has a charge of -2. Again, that came from the table of polyatomics. All right, so let's go ahead and match these up, do our little swap here. Okay, so be careful. Iron has a charge of +3, and sulfate has a charge of -2. So least common multiple in this case is 6. So I've got +3, -2. I want these to equal 0. So I'm going to multiply my 3 by 2 and my 2 by 3. So I have +6 and -6. And again, I get a net charge of 0. So my compound is going to be Fe2 and then SO4. Be careful with your parentheses here. All right, and then I've got KBr, potassium bromide. All right, now to balance, let's make our table. So I've got iron, SO4, potassium, and bromine. Same thing on the other side. Okay, so I see 1, 3, 2, and again, watch that 4. That 4 is part of our polyatomic, so there's just 1 there. 2, 3, 1, 1. Okay, let's go ahead and balance. So I'm going to start by, let's see here. Let's put a 2 in front of our iron on this side to balance it out. So that gives me 2 and then 6. All right, and let's balance our polyatomics. Let's put, now if you notice here, I've got a 2, this one is a 1, okay, but I'm kind of looking ahead here. I know that I need 6 bromines, okay, so I'm going to put a 6 here. That'll give me 6 here and 6 here. So even though I only needed 2 potassiums on the right side, I noticed I was kind of thinking ahead and realized that I'm going to need 6 bromines at some point to balance out. So I went ahead and put a 6 in front, even though I know I need 2 potassium. So I'm going to put a 3 here now. That'll give me 6 and 3. And we are balanced. So sometimes, like I said, when you're balancing, you got to go back and forth. You might need to tweak numbers to get everything to balance, but as long as you do the table method and you're careful and you keep track of everything, you will get the right answer. All right, we've got one more example here. So we're going to start by writing out our charges. So we've got sodium. Sodium has a charge of +1. Calcium has a charge of +2. And then our anions, chlorine has a charge of -1, and I believe this is phosphate, has a charge of -3. So we'll do our swap. And we have charges that don't match this time, so I've got a +1 and a -3. So to get this to balance out, I'm going to need 3 sodiums. Okay, and then here I'm going to need 2 chlorines because I have a charge of +2. So it'll be calcium, remember anion or cation first, Cl2. All right, let's make our table. Not Cl2, just chlorine. Okay, so I'm going to list out everything I have. All right, and then it's just a matter of balancing here. So let's see. Let's start with I'm going to go from the bottom up. Let's do the chlorines first. Okay. Actually, let's do the calciums first. Okay. So I notice that I've got 3 on the left side. So I'm going to put a 3 here to balance out. So that'll give me a 3. And I'm going to have 6 chlorines. Okay, so I need to balance out my calciums on the left side now. So I'm going to put a 6 here. That'll give me 6 sodiums and 6 chlorines. And then I just need to balance my sodiums now. So I'm going to put a 2 here. That'll get me 6 and 2. And we are balanced. So for homework, you're completing part 3. These are questions 1 to 10. And then the exit ticket is to complete a double replacement reaction. Be careful on this one because you do have lead. Lead is one of those where we don't know the charge, so we're going to need to look at the charge of our polyatomic here. Okay, so watch the charge on the polyatomic and remember there are 2 of them. And that is our lesson for today.